Today I'm going to teach you about the definite integral. A definite integral is the area between the curve and the x-axis. The definite integral of rate of change yields total change. You can see in the diagram the shaded region represents the definite integral. This is the integral of f from a to b. This curved symbol is called the integral sign and goes on the outside. Now, since this is a definite integral, it has limits, a being the lower limit and b being the upper limit. The function is the integrand, so in this case x is the integrand. Lastly, we have the variable of integration, which in this case is x, but if it were in terms of y, would be y, and so on. There are 4 ways to approximate a definite integral, and each way is a type of Riemann sum. The first way is an LRAM, which is a left-hand rectangle approximation. The next way is an RRAM, which is a right-hand rectangle approximation. Then there's the MRAM, which is a midpoint rectangle approximation. And then lastly, there's trapezoids. There are 3 ways to evaluate a definite integral. 1 with geometry of the graph, 2 with a calculator, and 3 with an antiderivative. We'll get into how to do all of those methods now. To start, we are going to do a problem with the geometry of the graph using the integral above. Looking at the integral, we can see that it has limits from 0 to 6, so we can think of the graph as being on the interval 0 to 6. When we graph this, we want to think of it as y equals 3 over 2x minus 3. For now, we are able to ignore the definite integral symbol because we will be finding the actual definite integral by using the equation. Now, as you can see, we have graphed the equation and shaded in the area of the interval. In a definite integral, the area above the x-axis is positive and the area below the x-axis is negative. So the larger triangle will have a positive area and the smaller triangle will have a negative area. To find these areas, we'll be using the equation for area of a triangle 1/2 base times height. So we can see that our base is 4 because 6 minus 2 is 4 and our height is 6. So therefore 1/2 times 4 times 6 is equal to 12 for the positive area. Now we will find the area of the smaller triangle. We can see the base is 2 and the height is negative 3. 1/2 times 2 times negative 3 is negative 3. Now all we have to do is add the areas of both triangles together to find the answer to our definite integral. So negative 3 plus 12 is equal to 9 for the total area, which is our answer. Now we will be solving a definite integral with the help of a calculator. To find the definite integral, you start by pressing the math button and then 9. You should see this shell of a definite integral equation if you've done this correctly. Now you plug in your limits, so 0 for the lower limit and 2 for the upper limit. Now you move inside the parentheses so that you can fill in the equation. 3x cubed minus 2x plus 5. And since this equation is in terms of x, your variable of integration is also x. Now all you have to do is hit enter and you get your answer, which in this case is 18. Here's a list of the most common integrals and their antiderivatives. If you don't see one of these in the problem that you have, you use power rule, which is listed as number 1. Here's our example, and since it doesn't fit any of our common integrals, we're going to use power rule to find the antiderivative. For the sake of power rule, we are going to call our exponent value n. To do power rule, you need to do n plus 1 in the exponent spot, but then also n plus 1 in the denominator. That gives us 3x cubed over 3, which comes out to x cubed as our antiderivative. Now that we have our antiderivative, all we have to do is plug in our top and bottom limits. You plug in the top limit to x cubed and subtract the bottom limit plugged into x cubed. That gives us 8 plus 1, which is 9, which is our answer. Now you know all about definite integrals.